Hello everyone, and welcome to this video on the impact of post-quantum computing on digital identity. I am Nat Sakimura, the chairman of OpenID Foundation and your host. In this video, we'll explore the potential threats posed by quantum computers to existing cryptographic algorithms and the implications for identity systems. We'll also discuss the challenges, considerations, and potential solutions to ensure the security and resilience of our digital identity infrastructure in a post-quantum world. The quantum threat. As quantum computers continue to advance, they pose a significant threat to widely used cryptographic algorithms like RSA and elliptic curve cryptography. These algorithms form the foundation of digital signatures and key exchange mechanisms in many identity systems. Adversaries may already be harvesting encrypted data with the intention of decrypting it in the future using quantum computers. This makes it crucial for us to address this threat proactively. Challenges and considerations. Transitioning to post-quantum cryptography, or PQC, presents several challenges. Standardization and adoption of PQC algorithms are still ongoing, requiring efforts to ensure interoperability and widespread adoption across the industry. Migrating existing systems to PQC algorithms can be technically challenging and requires careful planning to avoid disruptions and vulnerabilities. Performance and efficiency considerations also come into play, as PQC algorithms may have different characteristics compared to classical algorithms. Additionally, secure key management practices become even more critical in a post-quantum world. Potential solutions and actions. To address these challenges, we need to focus on several key areas. Designing systems with algorithm agility allows for flexible switching to different cryptographic algorithms as needed, facilitating a smoother transition to PQC. Implementing robust cryptographic hygiene, including using strong algorithms, regularly rotating keys, and protecting private keys, is essential to enhance security. Hybrid approaches that combine classical and post-quantum cryptography can provide additional security during the transition period. Ongoing collaboration among industry stakeholders, researchers, and standardization bodies is crucial to develop effective solutions. The OpenID Foundation's role. The OpenID Foundation plays a vital role in supporting the identity community in navigating this cryptographic paradigm shift. While the Foundation does not directly develop cryptographic algorithms, it focuses on promoting awareness about the quantum threat, working with relevant standards bodies to ensure interoperability and integration of PQC solutions within OpenID specifications. Providing guidance and best practices for implementing PQC solutions in identity systems and facilitating discussions and collaboration among stakeholders. Conclusion. As we prepare for a post-quantum world, proactive planning and action are essential to ensure the continued security and trustworthiness of our digital identity systems. By addressing the challenges, considering potential solutions, and fostering collaboration, we can navigate this cryptographic paradigm shift and build a secure and interoperable digital identity ecosystem for the future. The OpenID Foundation remains committed to supporting the community in this endeavor. Thank you for watching this video on the impact of post-quantum computing on digital identity. If you found this information valuable, please like and share this video, and don't forget to subscribe to our channel for more content on digital identity and security. Stay tuned for future updates on this critical topic.